Unit 5, Lesson 7. The y-intercept is a point where the x value is 0. The x-intercepts are the points where the y value is 0. And the coordinates look like this. So for the y-intercept, we have 0 and some y value. And for the x-intercepts, we have some x value and the y value is 0. The x-intercepts are also called the zeros of the parabola. Yep, or you could say roots as well. So this lesson is about determining the intercepts and their relation to the vertex form. So on the parabola below, we're going to highlight the intercepts and write the coordinates. So here we have an intercept at 2, here we have another one at 10, and so those are my x-intercepts, 2 and 0, and 10 and 0, and I have a y-intercept down here at -5. So 0 and -5 is my y-intercept. Okay, so let's calculate the intercepts given a vertex form of the equation. So how do I find the y-intercept from the vertex form? There's no c value here. So what you have to do is make x equal to 0 and find your y value. So here we go. Y equals 1 over 2. X is now 0. And then minus 5 squared minus 18. Solving for y, we get y equals -5.5. So it's just evaluating this whole expression. So again, y-intercept means x is 0, so make x equals 0 inside your equation, find your y value, and there it is, -5.5. So my y-intercept is 0 and -5.5. What about the x-intercepts? Well, you're going to make y equal to 0. Right? There's no factored form here. You just can't read the x-intercepts. So you have to find them by making y equal to 0. So here it is. 0 equals 1 over 2 x minus 5 squared minus 18. And we're going to solve for x by reversing bedmass. So reverse bedmass to isolate x. Okay, so that means I'm going to start with let's move the 18. Let's add 18 to both sides. So I'm going to have these two go away, and I'm going to add 18 on the left side. So 18 equals 1 over 2 x minus 5 squared. Right? Okay, the next thing I can do is multiply both sides by 2. Doing so cancels the 2 on the bottom with the 2 on the top, leaving me with the left side as 36 and the right side as x minus 5 squared. The 1 here doesn't matter anymore, just leave it as x minus 5 squared. Now, if you want to get rid of a square, take the square root. But whatever you do on the right, you got to do on the left. So the square root of 36. Now, when you take a square root of something when you're solving when you're doing this kind of problem, consider both the positive and negative square roots, right? Because the square root of 36 is not just positive 6, it is also negative 6, right? Negative 6 times negative 6 gives you positive 36. Okay, and the square root of an x squared gives me x minus 5. So I'm going to have plus or minus the square root of 36 equals x minus 5. And one more thing to do to isolate x is to add 5 to both sides. So I'm going to have plus or minus the square root of 36 plus 5 equals x. Now the square root of 36 is 6. So up here I'm going to write plus or minus 6 plus 5 equals x. So x equals two possibilities, 6 plus 5 or negative 6 plus 5. And these answers are positive 11 and negative 1. So my two x-intercepts are 11 and 0 and negative 1 and 0. Let's try another example. Negative 2 times x plus 3 squared. So the y-intercept means make x equal 0. So y equals negative 2 times 0 plus 3 squared. Solve for y. So y equals negative 2. 0 plus 3 is 3, so 3 squared. 3 squared is 9. 9 times negative 2 is negative 18. And there's my y-intercept. So 0 and negative 18. Y-intercept. X-intercepts. Make y equal to 0. So 0 equals negative 2 times x plus 3 squared. So start solving for x, isolating x. You can do that by dividing both sides by negative 2. So you can cancel those 2's out. 0 divided by negative 2 is still 0. The right side I should have x plus 3 squared. You want to get rid of the square, you're going to take the square root of both sides. Square root of 0 is 0. Doesn't matter plus or minus, it's still 0. And that leaves me with x plus 3 on the right side. So the square root and the square cancel out. And so that leaves me with x equals negative 3 as my solution. So that's my x-intercept. So therefore, we only have one x-intercept at 3 comma 0. Negative 3 comma 0. And so that graph would look like this. Negative 3, only one x-intercept. Okay, one more example. Y equals 4 times x minus 1 in brackets squared plus 12. So y-intercept, make x equal 0. So y equals 4 times 0 minus 1 squared plus 12. Do your BEDMAS properly. 0 minus 1 is negative 1, so negative 1 squared plus 12. Negative 1 squared is just 1, so 1 times 4 is 4. So I just have 4 plus 12, which is 16. So the y-intercept is 0, comma 16. X-intercepts. So y equals 0. So 0 equals, so make the y equals 0 in the equation. So 0 equals 4 times x minus 1 squared plus 12. Solve for x. So you can start by subtracting 12 from both sides. So minus 12 equals 4 times x minus 1 squared. Then I'm going to divide both sides by 4. So negative 12 over 4 is negative 3. 4 is here on the right cancel, leaving me with x minus 1 squared. Then I'll take the square root of both sides. So the square root of negative 3 equals the square root of x minus 1 squared. So that helps me with the right side. So the right side would be x minus 1. But on the left side, I have the square root of negative 3. So you can't square root a negative number. Try it on your calculators, you'll see you get an error. So if you can't square root of a negative number, then therefore you'd say that there are no x-intercepts. And so your graph might look something like this. Okay, so quick summary, calculating the intercepts. For the y-intercept, you're going to substitute in x equals 0 and then solve for y. For the x-intercept, you're going to substitute y equals 0 and use reverse BEDMAS, order of operations, to isolate or slash solve for x. And that's it. And that ends this video.